Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, I am gonna discussing about the cyberbullying detection using Python and machine learning. So let's have a look at the demo application first. So that's the demo application is called the cyberbullying detections using Python, and you need to enter one text. So I'm going to enter one text and click on analyze, and you can see this is the bullying. Okay, bullying types of text. So let's type here another text. Let's say he is a goat boy. Okay, and if I click on analyze again, and you can see here is non-bullying, and this is how the application is look like and how it actually work. Now without any further ado, I am going to start the tutorial right now. So let's go on here. Now it's time to make your hand dirty and try to do the coding part here. And for this case, I'm going to using here the Jupyter notebook. You can use here the Google Colab or PyCharm itself. So first thing first, I'm going to importing here all of the important library, which one is required to creating these cyberbullying detection projects. So let's first importing here pandas as PD so that we can read the dataset from my directory. Then I'm going to import here numpy as np, and as well as I'm going to importing here matplotlib.pyplot, okay, pyplot as plt for visualization purpose. And as well as I'm going to importing here the cborn as sns. Okay, so it's also one uh, visualization library in pythons. So using this one you can create some more realistic or more beautiful visualization plot using this library. Then after that I'm going to using here one style. So let's say plt.style.use, and let's say ggplot. Okay, that's nothing but the style type. Now I'm going to go on slowly. Okay, and importing those library which is required for creating this project. Also you need to import some another library as well. So let's importing here re, also called the regular expressions. Then we are going to importing here the nltk. So why nltk, sir? Why nltk? Because you're going to creating here one cyberbullying detection projects, and as well as the data set you're going to using it here is nothing but a string type of data. I mean textual type of data. So that's why you're going to using here this nltk. Using nltk we can do the further process on the data, right? As well as from sklearn, okay, sklearn dot feature extraction dot text. I am going to importing here tfidf vectorizers. You can also using here tf from your keyboards or getting the auto suggestions. So let's say tfidf vectorizers. Okay, vector. Yeah, you can see here it give me the auto suggestion, right? See, you can see if I press T and give the tab from the keyboard, you can see here it give me the auto suggestions. Okay, and again let's say given comma, and let's say T and again tap from the keyboard, and you can see here vectorizers. Okay, okay, so this is how it actually works. Let's say tf idf transformer as well, right? And then I can import here the count vectorizer as well. So let's say count vectorizers. Okay, you can see count vectorizer. It will auto suggest and also auto complete it. Trick, right? Trick. Say for this case, you're going to using here this tf-idf vectorizers. It's also called the term frequency inverse vector times of method. As well as you can using here the count vectorizer for making these full projects, right? So for this case, you can using here tf-idf because it's more faster and it not taking much more amount of memory. Whereas this count vectorizer take much more amount of memory for the calculations, right? Then what I can do, then from nltk, the we are going to importing here the send tokenize. Okay, send tokenize. Okay, for tokenize your data, right? And as well as the word tokenize. So let's say word tokenize. We just import it. If it is needed, then you're going to use it. Okay, now from sklearn dot matrix, we are going to importing here the f1 score, and otherwise also you're going to using here the accuracy score. So let's say accuracy score, then using here the precision score, then as well as you can see precision score, then we can using here the recall score, then you're going to using here the make scorer. So let's say make scorer, so for getting the full score. Okay, then I'm going to importing here the time module. So let's say from time, I'm going to importing here the time, right? So why time is needed? For calculating the time for execution. Okay, I mean how many time is taken for the training period. Okay, then I'm going to importing here the pickle. So let's say import pickle, right? Pickle. That's it. Shift enter, and it will loading this library in my Jupyter notebook. Okay, so you're importing the model one in the high end the coding part is done, and how you go for the model architectures or building our machine learning models. Then you're going to importing here the all of the model which one is required for building these applications. So now let's say df equal to pd dot read underscore csv, and then inside that I can beam here my path. Let's say dataset dot csv comma separated below, and you can see here my dataset is loaded right now. And now if we're checking this one, let's say df.head, it having some uh, bad word in this, so just ignore that. Okay, but in our data set you can see the label we have is -1. It's -1. So what I can do, let's checking for the labels first. Is we need to do some operation on that. So let's say unique. Okay, and you can see it having -1 and 0. That's mean it's not 1, it's -1. So what we need to do, we need to convert them into 1. We need to convert them into 1, right? So we can do the data frame manipulation. Why manipulation? Because we have the data with having the -1 and 0. So we can pass this -1 into our machine learning model. We need to passing here 1 or 0 like that. That means this is an supervised machine learning problem, as well as this is a binary classification problem, right? Well, and now we need to do the data manipulation. Let's go on the markdown, and after that I can use these ones. Okay, now let's define one function which call perform. Let's say data manipulation. Let's say manipulation, and it not taking anything else, just a function that you're going to calling it out. And which one is reading the data frame? So we can copy this out. We can just copy this out. You can also do it manually without any functions. Then after that, what I can do, we're going to first checking that if the index, I mean for the index is df.index, I just taking all of the index, this index number from the data set, and when I get the index number, then I can get this label from the index number as well. So how can I do that? So if the df.ilog or log are the locations, if the df location is nothing but index and passing here the label, that's mean if the locations of the data set it having the labels, and if the label is equal to if the label is equal to -1, so what I can do is simply going to convert them into 1. We can simply convert them into the 1 in the same location. So you can using here the same thing, that's the index, and you can giving here the label, and after that you can making it 1. Okay, making it 1, simple. Then after that we can return here my df. So let's say return the df, right? Now if I using the shift enter and try to calling this method, okay, and try to put it in the same variable name, and let's say df.head, then you can see here it's converted into 1. It converted into 1. If I copy this one just to white, if I copy this one and if I paste it here and try to shift enter, and you can see 1 and 0, 1 and 0. That's when our data manipulation part is done. Data manipulation part is done. Now what I can do, we can first checking that how many value are 1 and how many value are the zeros, so that we can check that if the data set is balanced or imbalanced. If the data set is balanced or imbalanced. So how can I check that? We can check that using a pie chart. Using the pie charts. Okay. So let's checking that my recording is starting or not. Yeah, recording is started already. Sometime I forget to actually click this record button. Okay, so let's go on here. So let's create a pie chart for data classification. I need to check that how many classes are on there and how many percentages. So let's say classification, let's say using the pie chart, right? So you can go on the markdown and use here. Let's take some more shell as well. So let's define here a function. Let's say our method. Let's say perform data. It's called a distribution. Just checking that how the data is distributed. So it's taking the df. Okay. And we are going to using here the same technique. I mean, we're going to creating here all the method and try to make it inside one method so that you can call it again and again, right? So this is the best practice to using a method in these machine learning problems. Okay. So let's say I'm going to using here, let's say df dot shape and taking the first one. So why first one, sir? Why first one? Let's go on here, just taking another shell. If I using here df dot shape, see df dot shape, you can see here, this is nothing but the row number. This is nothing but my row number, and this is nothing but my column number. Column number, I mean labels. Okay, labels. Sorry, column number. How many columns? I mean headline and the labels are nothing but the column number. How many rows it have? It have 18,148 rows. That means this kind of data. This kind of data are available on my data set. That means this is my total number of row. Total number of row. So how can I get that? If I using here 0, then you can see I got the first index number. That's mean total number of row. I mean total number of features are available in my data set. So that's my total. So let's say total. Okay, total. Now what I can do, we need to first calculate the non-toxic. Let's say number of non-toxic. Okay, you can also calculate the toxic one. You can calculate the toxin. Now let's see what actually happening here. So let's say try to calculate them. If the df of df dot label, you can also using this one like this one in the new version of pandas. Otherwise you can also using like that. Okay, you can give him the label. You can give him the labels, right? So let's give it here. If the labels is equal to 0, is equal to 0, let's take in the first shape. Let's take in the first shape, non-toxic one, non-toxic one. See, if we go to the df and we're checking inside my label is equal to 0, then we get in the first shape. That's mean how many numbers are nothing but non-toxic, right? And now what I can do, we can first getting here a slice so that we can pass it inside our pie chart, our pie charts. So let's say slices. So how can you calculate the slices? Simple. Number of non-toxic, this is the formula. You need to actually remember that. Divided by total. Divided by total. Then what I can do, you need to do passing here one thing, total minus number of non-toxic, okay, non-toxic divided by toxic. Sorry, total. See, number of the non-toxics divided by total. Okay, and we have one comma, then total number minus, I mean total number of your data frame minus number of non-toxics divided by total. So what actually happening here? Slices is nothing but how many slices can be happen. How many slices can be happen in my pie chart, in my full pie chart. If it is a circle, how many slices? Because it have the two data set, right? I'm sorry, two classes. That's mean it having a two slice. Now the question is how many percentage? How many percentage should be there? Okay. So now let's get here on labeling first. So let's say labeling equal to, let's say first say let's give one list because it have the two levels. So number of, let's say let's say non-toxic, toxic, and the toxic types of labels. Now let's giving here an explode because we need to pass it here. Let's say 0.2 comma 0. That's fine. It will do okay. Now let's see here. Now inside my pie chart, so let's say plt.py, because we're using here the matplotlib. First, you need to pass here the slices. Let's pass here the slices. Then we need to passing here the explode. So let's say passing here the explode. Then you need to giving here shadow equal to true. Okay, should be the true. Then you need to giving here the auto PCT. So let's give it here percentage of 1.1, percentage of percentage, and then as well as I need to giving here the labels. So it's nothing about my labeling, right? And I need to giving here another property called the wake props. So what I can do, you can giving here some color. Which color I'm going to choosing that? So let's say H color. H color, let's give it here the black or the white, whatever you can give it here. So let's give it here the, I mean the, it's nothing but the border. Okay, let's give it here black. Black should be the great for that. Okay, fine. And then, oh, not like that. Okay, fine. So then we're going to giving here one title. So let's giving here one title as well. So let's say plt.title, and inside there let's give it here number of toxic versus non-toxic. Okay. Toxic. Okay, test sample. It's a test sample. And then we can giving here the title layout. So let's say title layout, and then we can giving here plt.show. Okay, it's loading. Now let's copy this out and simply going to passing here the df, and let's see how can you got that. You can see we got two slices is 35%, 35.7% of the non-toxic, and 64.3% are the toxic. Okay, data set is not imbalanced. You can also balance this out, but I don't think that it's imbalanced. Okay, it's quite okay. It's quite okay for building the machine learning model. Okay, now what I can do, uh, we checking that we first know that the data manipulations, I mean uh, manipulation just because of it having the -1, we convert them into 1, and as well as we first checking for the data distributions using the pie chart, so that we can see that is there any imbalancity or not. Okay, and we saw that data set is right and data set is cool. Okay, so you don't need to do the operations. Now what I can do, let's try to remove the pattern from here. Okay, remove the pattern. So remove the patterns, and as well as you can also checking that is there any null value or not. You can also remove them as well. You can also do missing, handle the missing value as well. Okay, it's your text, but I don't think that it have the missing value. Okay, so that's why I leave it out. Now let's give here one input text. So input txt, then let's say pattern. Okay, now what is actually pattern here? What is actually patterns? So see, because this is a textual data, it having some noisy things. So you need to remove them noisy thing from our data set. So that's why we're defining here functions called the remove pattern. So for that, you're going to using here the RE. That's RE. I mean regular expressions. But before that, you're also checking that if the input text is coming, is it a string or not? If it is a string, then we can further do the operation. So how can I check that? That's if the data is coming, I mean if the type of my input text, let's say input text is coming is equal to string, then we can do the operations. Which operation? We can find all the pattern in our data set. In our data set, let's say give it here pattern. Okay, pattern, and the input text, let's say input txt. Okay, so this is my regular expression. So let's say using here R. Now from these regular expressions, we have all of the data in a list format. So what I can do, we can do the iterations. Let's say for I in R. Then after that, we can add it inside my input text. So let's say input text equal to re.sub, and after that you can pass in here my I, and with the blank space and the input txt. That's input txt. Okay, that's why txt, right? And then after that you can return here the input text. Return here the input txt. Fine. Otherwise, if it's not a string, we can simply going to return here a blank string. Okay, so you can see it running fine. Now what I can do, we are going to creating here another method for dataset cleaning. So why this remove pattern is needed? It's help us to removing the pattern from our dataset. Now see, we have the input text, but what is pattern? Right? Pattern क्या है भाई? So pattern तो हमको initialize करना पड़ेगा. I mean getting from a dataset. So that's why I need to define here another functions called the dataset cleaning. So let's say def dataset cleaning. Question is why dataset cleaning is needed. See, in our data set, maybe it having some unnecessary text, just like the @ or the extra letter, or let's say those letter who is not less than the 3. Okay, thoda kam letter hai, so why should you using these ones? That's called the data set cleaning. So from this data set cleaning, we can get some pattern. So that's why we're using these ones. Okay. Now what I can do, it will taking the df, and now first checking that we have the headline. Okay, let's try to first checking that. Okay, let's try to getting the first length of my headline. So let's the length of the headline. Okay, then what I can do, we can getting it from my dataset. So let's say from headline. Okay, headline dot string dot length. So it will give me the length of the headline. If I go on here, just it's better we can show the dataset on here because it has some bad word. So that's why. Okay, let's give it here just one. Oh, okay. Okay, you can see it just having a headline and as well as an label. So what I can do is first going to actually taking the length of the headline, and try to add it inside a new data frame. So inside a new column in the same data frame. Let's say it getting here a new features called the length headline. Then what I can do is simply going to combine them. So let's say combine df equal to df dot append equal to df, and we can go ignoring here the index number. Let's say ignore index equal to true. Let's say true. That's it. Okay, that's our combined df. So we can giving here this one, you need to giving here this one, and then what I can do, we're creating here a new data set called the combined df. We're creating a new data set called the combined df using these ones, length headline. If I try to return it, let's say try to return here this combined df, and then you can see, let's say data set, and you can see the data set passing in the df, and you can see just what, okay, data cleaning set is not defined, and it also running this out, and you can see it combine them and creating here an extra column called the length headline. So let's remove this one because it's not needed right now. Then when the dataset is combined with this headline, length headline, now what I can do, we can remove the pattern. First checking the pattern, and after that we can call in this remove pattern method. Okay, so let's say np dot vectorize, okay, vectorize, and we can using here the remove pattern method, and then inside our pattern we can go on the combined df, and inside this combined df we have the headline. Now the question, what is the combined df? Let's try to do it again, just to wait, return here the combined df, because मुझे तो ऐसे ही जाना पसंद है, so ऐसे ही जाते हैं, इसको यहाँ पर जाके df दे दिया. Okay, so you can see inside my combined df what you have, because this is the combined df that you're going to return here. In my combined df, see combined df, it have the headline as well as the length headline. Now from the headline is nothing but my actual text. How are you going to do the pre-processing? Now from the headline, we can removing the, let's say we can using here, let's say remove @user. So why the @user? Because this is Twitter data, because we collect the data from the Twitter. So that's why it having some @ of the users. We need to remove them. That's the @, and you can using here w and \w and as well as the star. So that's a star. This is how you can actually remove the @ of users. Now let's do copy this out and try to paste it here. So let's say this is not my tidy tweet. That's a tidy tweet. Okay, tidy tweet. Now we need to remove the extra letter space as well. So what you can do, you can say that remove extra letter. Oh, letter kya hoga? Okay, that's it. Now we can using the same thing, I mean same variable name, not same thing. Then after that you can using here this combined tied to it dot string dot replace, and inside that you need to replacing here with the extra letter. So what I can do, you can giving here one colon, then you can giving here this what is called, sometimes I actually forget the expression. Okay, you need to giving here this tube sign, a to small z, okay, and a to capital Z, okay, a to capital Z, as well as the hashtag. Okay, so we're simply going to replace them with the blank space, with the blank space. Okay, just remove the stat space from my data set, just replace it. Now let's try to remove all those words with the size less than 3. I mean less than 3 word, we're simply going to remove them. Let's say in our data set, if the word is using the just less than 3, so why should you be using it one? Because it's unnecessary text. It's unnecessary text. So you can remove this as well. We can remove this as well. So let's say combine df and combine df, and now you can using here the apply method. So let's say apply, and you can using here the lambda method. There's lambda, and you're using here x dot, and you can using the blank space dot join, and then we're going to check in that if the length is, if the length of my word is greater than 3, then we can take it there. We can join these ones. So how can we join them? We can creating here a method, okay, and inside this method I need to using here one, okay, also using here, is there any extra spaces happening here? Yeah, we can remove this one. So for w in x dot split, okay, now it will find if the length of the w is greater than 3, then we simply going to split it and put it inside my tidy tweet, cool. Okay, then then you're going to calculate the actual length of the tidy tweet. So what I can do, you can using here combine tweet dot steer dot length, same thing. Then let's give it here the same variable name, and just changing this one, it should be the length of the tidy load, okay. Then what I can do, we can simply go into creating here a list for the tokenize. So let's say this one tidy tweet dot apply, and inside that we can using here the lambda method again. So lambda okay, it's called be lambda, lambda, okay, that's x dot split, just getting here a list of that, okay. Let's call the combined df. So it's nothing but creating a list of that. So we can using this, let's say we can say that let's say tokenize. Why actually using this one? It's simply going to be creating here a list, and we simply passing this to it inside my tokenizer, because we also importing here this analytica, right? Using the analytica, so you can do the tokenizations as well. So let's try to go on here and try to do the tokenize. So let's making a heading called tokenize, okay. Then let's say it's called, let's say tokenize, okay, let's say tokenize tweet, okay, tokenize tweet, like this way, okay. That's a list. Now we can pass in this list inside my tokenizer method. So for that we need to using the analytica. That's analytica dot download, and we can using here the word net. So let's say word net, it's already installed in my system, and no problem, it will working. Then we can creating here an lemmatization technique. So let's say analytica dot steam dot word lemmatizer. So let's word lemmatizers, and after that we can creating here a variable of that. So let's say lemmatize, okay, let's say lemmatizers, fine. Now we're simply going to using here the tokenizers that actually creating here the list of that. So we can using here, let's say tokenize tweet dot apply, and we can passing here the lambda method of the x dot, and you can using here this lematizer. So lematizer dot lematize, okay, lematize, and after that you can passing here the I, let's say for I in x. Okay, so that's nothing but my tokenized tweet. Okay, that's nothing but my tokenized tweet. So you can do the same variable name as well here, because we applied the same variables. Now from this tokenized tweet, from the tokenized tweet, we can getting it, because this is a list, so you need to also creating here the iterator. So let's say for I in range of the length of the tokenized tweet, and then we're simply going to join it. So let's tokenized tweet of I equal to join with the blank space. Let's say join with the tokenized tweet of the I. Same thing. And then what I can do, you can simply going to combine them. So let's say combine df equal to tokenized tweet. Okay, tokenized tweet. Now we need to do the same thing on here. Let's copy this out, and after that, so what we do actually, so first we're going to calculate the length of the headline. Then we remove the users @users, remove the extra letter, and remove the word which is less than 3. Then after that, we simply going to apply here the tokenizer, and after applying the tokenizer, we get here one list. Now we are getting the list from inside a tokenized tweet variables, and after that, we're simply going to passing it inside my tokenized tidy tweet. Okay, and the same data variable name. Now what I can do is simply going to return them. So what I can do is simply going to return it. So let's say return the combined df, and as well as my df, I mean my data set. Okay, invalid syntax. So किधर शायद इधर पे होगा. So let's check in these ones. We have the join, we have the lambda x dot join, and we have the, okay, we will be giving here w as well, because you need to also passing this here w for w in x dot split. If the length of the w is greater than 3, then we can taking this out. Let's try to run it again, and now it's running cool. And now let's try to copy this out, and after that you can pass it here. Okay, then you can passing here my df. So this is nothing but my df as well. So let's say df. Okay, let's say df, and as well as this combined df. So let's copy this out, and here we go. Okay, problem आ गया है, इधर problem. Okay, input text is not defined. Okay, शायद यहाँ पर है input text. Okay, input text. Okay, I think now it work. Okay, modular regular has no attribute called final. Okay, it should be find all. It should be the find all. Okay, now I think it will work. Yeah, it's working fine now. Hope so. You have to replacing them. It's error down on the net. I think I need to open my network connection as well. Okay, I think I need to open the network connections. Let's connect my internet connections. Yeah, I reconnected because the broadband connection is gone somehow. Okay, I think it's now downloaded this WhatNet, and it already downloaded in my folder as well. You can see here, I already downloaded. Package WhatNet is already up to date. I mean, it's downloaded, I hope so. Okay, now you can see we have the combined df, and as well as my df. So now what I can do, we can do the data splitting. I mean, train, test, and split, right? And after that, you can apply here the machine learning algorithm, right? So let's say data set, क्या बोलते इसको? Data set splitting S होगा ना, splitting. Let's go on the markdown, and let's try to do the data splitting here. Okay, and you already importing here the train test split or not yet. Okay, so you need to also import it. So let's say from sklearn dot क्या होगा, फीचर सिलेक्शन पे है और द मॉडल्स पे है. तो ये है मॉडल सिलेक्शन पे, selections. Okay, we're going to importing here the train test split. Okay, let's run it out. Can I import the train test split for the sklearn.model selection or the selections from sklearn? Okay, it should be not test. Okay, it should be the train test and split, not train text. Okay, so our train text split is running, so now we can apply here it. So let's taking some another shell as well. Okay, and let's try to define here. Let's say defab. So perform data split. Okay, so what I can do, pass the x and y and the combined df, and another df. Well, okay, so first thing first, we're going to using here this train test and split, and inside that we can passing here my combined df. So let's start to checking it out, this combined df, that is really working or not. So combined df dot head, yeah, it's working fine. You can see it has the headline, the levels, the length headline, the tied to it, I mean my clean to it, and the length tied to it length. Cool. Okay, so what I can do, you can passing here this combined df, and inside that we can passing here my tied to it. So let's say tied to it. Okay, this is my x and y should be my level. So let's say combined df equal to my levels. So I'm not actually building here any machine learning models. You have to divide your data set into train, test, and split. So 80%, generally 80% for the training and 20% for the testing. Okay, you can use any of them. You can using here, let's say 30% for the testing and 70% for the training purpose. You can also use these ones. Okay, so let's keeping here the x should be my test size. So test size should be my x, and let's giving here the random state. You can passing in, let's say y. Simply going to passing it here. You can see we define here the x and y. So x is nothing but my test size, and the random state is, I mean, if it is not actually changing these ones, so we pass it here as well for the y random state. You can also give it here default, by default as well. By default, random state is nothing but the 42. You can also give it here like that by default. If you don't give it, it's by default taking this one. So let's say this should be the x train. Then we have the x test, then y train, and the y test. Here we go. Okay, fine. Now this is the x test and the y train and the y test. Now you can also printing this out. Let's say print here, just getting here one print statement. So let's say number of rows in the total data set. We can using here the format specifier. So you can using here this f string as well. So let's say using here the f string, and you can pass it here. Let's say combined df of the shape of the 0. Okay, and let's try to copy this out. कॉपी करना है मुझे, इसका बाद इधर पे जाओ. Okay, so combined df is here. You go, you can see combined df, and we're going to checking the shape of the x string, and as well as checking for the x test. Okay, x underscore test. Okay, and it should be the training set, I mean training data set, and it should be the testing set, I mean test set. Let's make it train data set. Okay, that's for checking purpose. Now, because we're going to using here this tf idea vectorizers. So for that, we need to using here one stopwords. Why stopwords? Because stopwords is not needed. We can remove them. So I have a stopword in my folder. You can see stopword.txt. You can also using here the analytical library, which one having the by default stopwords. You can also using these ones. You can also using this technique, this txt technique. So let's checking this out, how can I actually open one file in Python. So let's open, and we're to giving here my stop words. So let's say stop words dot txt. Okay, and we're to giving here the mode. So let's say it's the read mode. Then let's say this is nothing but my file. So let's say it's called files. Okay, then from a files, I'm simply going to read it out. So that's nothing but my content. So इसको content बोलते हैं. I mean my content. Now let's say split it. So let's say content dot split. So why should it split? If I go on here, just out of that, and if I open this one txt file, you can see here this is nothing but txt file. Now see, after completing this word, it will go to the new line. It will go to the new line, new line, new line, new line. So you can split it using the new line. We can split it with the new lines. Let's say go on the new line. Okay, then what I can do, this is nothing but my content list. Let's say content list. Okay, content list. Now simply going to close the files. Let's the files dot close. Files dot close. Here you go. Okay, you can also copy this out and try to checking this out, is it working or not. So if I go on here and try to run in this one, and you can see if I have the content list, then you can see all of the list, all of the value in the list. You can see content list. That's my content list. It's needed. It's needed. Right? Let's try to removing this one. I don't need this one as well. Okay. Now what I can do is simply going to apply here the tf idea vectorizers. So tf idea vectorizers, and inside that you need to giving here the stop words. Stop words. Okay. So stop words is equal to my content list. My content list. This is my content list, and the lowercase. Let's make it lowercase equal to true. Convert them into the lowercase letter. So let's define into a variable called as tf-idf vectorizers. Okay, let's say vector. Okay, tf-idf vector. Fine. Then we're simply going to fit it in our training data as well. So let's say tf-idf vector, this vector, and you can using here the fit transform, and after that inside the fit transform, we're simply going to passing here my xstring and dot values dot s type. We're simply going to give here my unsigned integer. You can give it here the simple text shortcut technique. You can using here the u. Okay. Then we're simply going to put it inside a variable called training data. And after that, we need to do the same thing for the testing as well. Let's copy this out and paste it here. But instead of fit transform, we need to using here the transform on the text data. I mean test data, not text data actually. It should be the test data, testing. Okay, it's a test data. Okay, like a testing data. Then what I can do is simply going to dump our pickle file. So let's say pickle dot dump. Just simply going to dump here my vectorizer file. Let's using here this vectorizers. Okay, let's vectorizer dot vocabulary. This one with underscore sign. You can see with underscore sign. Careful. And using the open method, and inside that we need to give him a file name. So file name we can simply going to write it down. Let's say file name equal to tf-idf vectorizer dot pickle file. That's a pickle. Okay, cool. Now what I can do is simply going to return it here. So let's say return here the xstring and the xtest. Okay, then ytrain ytest and the testing data and the file name, and as well as the training data as well as the content list. Let's say content list. I mean this content list. Okay, so what I can do now is simply going to run it out. Okay, syntax error. Okay, non-default argument follows the default argument. So I think I need to removing this one. And let's give it here perform the data set split. And inside that, you can simply going to pass in here all of the things. Let's say passing here, let's say 0.20% for the testing. We can passing here, let's say 20%. Then giving a random mistake, let's say 43. Then let's say combined df. So combined df and as well as my df. Okay. So now what I can do is simply going to copy this out, all of the things, because it is returning this ones. We're simply going to pass it here, and here you go. I hope so it will working fine. Now you can see it is starting the work. How many total number of row and how many row for the training set and how many for the testing set. Okay, cool. Now we're simply going to apply here the machine learning algorithms. Let's say apply machine learning algorithms. Machine learning algorithm. Okay, so let's go on the markdown and let's create a pipeline for the machine learning algorithm. Okay, so let's take some shell and creating here a variable called, let's say, pipeline. For create the pipeline for the machine learning model. So let's say xtrain and then ytrain and as well as the xtest and the ytest. Right, let's make it pass right now. Okay, and before that we need to also importing here all the model which we are going to using it here for building these applications. Okay, so let's start to import it. So let's say first importing here the xgboost as xgb, then from sklearn dot nebias we're simply going to importing here the multinomial nb, then from sklearn dot tree we importing here the decision tree classifier. Okay, decision tree classifier, then from sklearn dot svm we importing here the linear sbc, then from sklearn dot ensemble we importing here the ADA boosting. Then we have the, because this is a classification problem, so it should be the ADA boosting classifier. Then we can using here the random, because random forest classifier as well as inside ensemble method. We can using here the bagging classifier. Then from sklearn dot linear model we can importing here the logistic regressions and as well as the SGD classifier. Okay, then you can also import it the KNN. Let's say from sklearn dot neighbors we can importing here the k nearest k neighbors classifier. So those are the machine learning model we're going to using it here. I just importing all of them. Okay, so now let's try to use one of them, I mean one by one, and try to creating the pipeline of that. So let's say getting here a list of the models. Let's say let's say models equal to, let's say first let's say using here the linear SBC. Then what you have, we have the logistic regressions. So let's say logistic. Then we're going to using the multinomial NB, I mean my nebias, and the decision tree. That's a decision tree classifier. Then we're going to using the ADA boost. Then we're going to using the bagging. Okay, we can go on the next line from here. It's a bagging classifier and as well as the SGD classifier. Okay, SGD classifier. So that's nothing but models that you're going to use it here. Now let's try to check the length of the ytrain. And this is nothing but a size of that, because using this one you can also throw the training part as well, because you need to also having the length of that. Okay, Then what I can do, we simply going to taking all of the models. So let's say model in models. Okay. Then what I have, we can creating here a list. So let's say results. So here you can store all the things with the algorithm name. So let's say results of the, let's say, algorithm. So algorithm. Okay, I mean all of the algorithms. So let's taking it. Let's say models. Model dot underscore class underscore dot name. So which one giving here your name of your algorithm, and to the storing it inside your algorithm fold as algorithm. Sorry, result actual list. So it will result dictionary, not list, actually dictionary. It will storing them with the algorithm as well as the name, right? Then after that we can using here one timer, so that we can also calculate the training time. But before that, let's try to fitting with the model. So let's say fit, and you can passing here my X train and as well as the Y train, right? Now we can, let's try to calculate the time. Let's say start equal to time dot time, and as well as the ending time. Let's say end time. Let's say end equal to time dot time. Okay. Now you can also give one print statement how many time it will taking. So let's say f string training time. Okay, we can give it here on the specifier. So we can giving here the model, this model dot class name. You can pass it here. Okay, training time is taken for that. Okay, fine. Now let's try to do the same thing for the testing as well. But before that, let's try to save it in a pickle format. Pickle file, I mean the which model is coming. The first model is coming. Let's say we're simply going to save it out inside my directory. Let's say first model is coming. Let's call the linear SBC. So after training part, we're simply going to dump it inside my pickle file. So let's say giving here on file name. So let's say file name equal to, let's say model dot underscore class underscore dot underscore name. Okay, and we can simply going to add it on dot pickle extensions. Let's pickle. Cool. So it my file name, then we're simply going to dump it out. Let's pickle dot dump, and after that we can give here the model, and as well as simply going to open here and giving here the file name and as well as the WB mode. Okay. Now we're simply going to store it, this training time, inside my results. Let's say results. We have the training time. Let's say training time T capital होगा, time equal to end minus start, and minus start is my training time. Okay, now let's try to do the prediction time. So we can copy this out and we can paste it here, and what we can do, we can removing this thing. We can using here so model dot predict with the test data text, and this is my prediction tests. Let's say prediction tests. Okay, and let's do the same thing for the training as well. So prediction train equal to model dot predict, and we have the X train data. Okay, for the training and the testing. Okay, and let's try to store it inside the results. So let's say results, and we can give it here the prediction time equal to and minus start. Well, start. Fine. Now our prediction time and the training time is completed, but you need to also calculate the accuracy, F1 score, and all the things. Okay. So what I can do, you can directly put it inside that. So let's say results of the, let's say first accuracy accuracy of the, let's say first, let's say test data, accuracy of the test. Let's say using here the accuracy method, and you can passing here my y test and as well as my prediction test. Let's say prediction test. Okay, so you can copy this out and do the same thing for the accuracy of the train. So let's make it train. Okay, then instead of the text we can passing here my y train data, and instead of the prediction test we can passing here my train data. Okay, it's prediction 10. Now let's copy this out, this accuracy text, and then you can do pass it here. Let's say for the F1 score and the precision and the recall. So let's say this is the F1 score, precision and the recall. That's it. Fine. Now let's try to changing these ones. Just changing few things here. Okay, fine. Training test, and this should be the F1 score. So it should be the F1 score, and it should be the F1 score, and as well as this should be the F1 score. Let's say F1 and score, F1 score. Just press the tab from your keyboard, and this is nothing but for my precision. So let's say precision. Okay, precision test. It should be the precision test, precision score. It should be the precision score, and let's try to copy this out and try to paste it here, precision score. And then this is for the recall, and copy this out, and it should be the recall score. With the recall score, you can say recall score. Cool. Okay, now what you can do now, we can simply go into print it here. One thing, let's say print. Okay, we can printing here the training time on here. Okay, my electricity is gone. Okay, so I'll back again. How the electricity is coming because यहाँ पर अंधेरा है. Okay, let's try to back again how the electricity is come. Well, so now let us start again. So let's say training. That's a finished. Okay, FANISHED finished in. Let's say giving here one format specifier. So let's give it here the F, and then we can giving here, let's say we can giving here a model. So let's say model dot underscore class underscore name, and then we can giving here my time in a second. So let's say using here second, and it should be my training time. So I need to give it here like that. Let's say results, and from that I have my training time. So let's say training time. Cool. So you can get here the training time as well. Now what I can do, we simply going to append all of my result inside and list. Let's say final result is equal to and list, and now we're simply going to put it the value inside my final result. Let's say final result dot append, and inside that you can give here the copy of my result, results dot copy. Okay, if I go down up, you can see results. Cool. Now what I can do is simply going to return it. So let's say return here the final result. Okay, it's running fine. And now let's try to copy the pipeline, and what I can pass it here, we're simply going to pass it here our training data. So let's say training underscore data, then as well as my y train, and then I have my testing data, and then I have my y test data. Okay, so this is nothing but my final result. So let's try to use it. Let's say final result as result. Fine. Okay, so we got some error. So built-in function or method object has no attribute called time. So we can remove this because we already imported from time. So that's why this kind of error, and we need to do the same thing here because we import it just like the from time we imported the time. So we don't need to actually use this one. Okay, so we got another error. You can see found input variable with inconsistent number of sample. If I checking on here, why this error? Why train? Why testing data? Testing data, the file name, the training data, and as well as the content list. So why this error? If I go on here and you can see in the pipeline, I got here this and to start accuracy score and number of sample is coming up from here. In the predictions, let's see what kind of error we actually got. Yeah, it should be the X test, right? The same time again. So we can check this out. I have it working fine. Linear SBC object has native call class underscore name. इतना एरर यहाँ पर शायद मैंने डॉट देना भूल गया. Class underscore name. And if I checking this one, you can see class underscore name. We need also giving a dot on here. So I think so. It's coming up here. Yeah, here you go. That's why this kind of error can be happening. Linear object has not been called class. Why it's coming up here? Yeah, it's coming up from here. Model. I mean this model dot class dot name. Okay, it should be the underscore here. Okay, this kind of a linear object has also called class. Again, same error. Yeah, it should be the underscore. Yeah, now it is working fine. I hope so. Yeah, it's working fine. This kind of simple error you can get. I need actually doing this coding part here. Okay, and you can see it's working fine. It's better we can run it from the beginning. Let's run it from the beginning. From here. Yeah, that's right now. Good. Okay, शायद यहाँ से run होगा. We can. Let's try to interrupt the kernel, and then we can run it from the beginning. I hope so. Okay, let's close it. Yeah, closing, and now let's try to run it from here. Because we do one mistake on here in the testing data, so that's why it's better we can run all of the shell from the beginning. It's a best practice because it's already creating here the file that's called the tfidf backtracer file. So that's why it's better we can run it from the beginning, and it will creating here the automatically creating and try to put it inside the same vectorizers. Okay, because it's create the vectorizers. Okay, so here I go, and you can see the training time for the SBC is finished in 0.34 second. Training time for the logistic regressions is nothing but 3.53, and for the naive bias it will take 0.001, quite in the lowest number. Then you have the decision tree classifier taking much more amount of time, actually 80 seconds. Then the ADA Boost classifier taking 8.62. And now let's waiting for the bagging. I hope it will take more amount of time, the bagging one. Well, so our model training is completed, but before creating a float, so we can also creating here on data frame. So where you can check the minimum and the maximum value as well. So let's try to define here a method. Let's say perform, let's say final result. Let's say final result. Okay, it will take in the final results. So final results. Okay, and then what you can do, you can convert them into the data frame. So let's say data frame, and inside that we can pass in here my final results. So let's say results is now converted, and let's say making it call results. Okay, then we can do the reindexing. So let's say results dot reindex, so that it's look cool because it having some mismatch on that. So you can simply go into just like that training accuracy and the testing accuracy, like just like this, just for the reindexing. Okay, let's pass it here, and it should be the algorithm, then the accuracy, then the precisions, and the recall, the f underscore, and the accuracy train and the precision train and the recall train and as well as the F1 score train and the training time as well. Okay, so why this gap? Why this gap? If I go up, you can see it having some gap. It having some gap. Why I'm simply going to putting this out inside my result folder. I mean my result dictionary, right? Now simply going to store it, and after that you can also short it out here. So let's try to short it out. Let's short values by, let's say we can using here the F1 score because this is one kind of text, just like the yes or no. So we can focus on the F1 score. So let's say test, and then we can make it, let's say in place equal to true, so that it can replacing the value in the same positions, and you can give it to the ascending equal to, let's say false. In a descending order, you're simply going to check this out. Let's say return here the results. Okay, and again थोड़ा error आया है यहाँ पर. I think okay, it should be the single one. That's why this error, I think so. Yeah, now the error is gone. So what I can do now, we can simply going to calling this perform final results, and inside that you can passing here my final results. Okay, final results that we created on our functions. Okay, let's say results equal to, and now okay, final results is not defined, so it should be the results result. So that's why this error, final result. Now we can checking this one. Let's say results dot head, and then you can see here the first one is called the decision tree classifier, the backing, the linear spacing, the logistic regressions. And if I using here, let's say 10, so all of the things it actually happening up here. You can see here the decision tree classifier, the bagging classifier, linear SBC, logistic regressions, the SGD classifier, multinomial NB, the ADA boosting, right? And you can also describe it. That's the results dot describe, and after that you can simply going to using the log functions and try to getting here the minimum and the maximum value on here. So let's say minimum and the maximum is nothing but the descriptive analysis of the results. You can see it having the minimum, maximum. Okay, so let's try to take it out. We can also remove this index from here. So let's try to remove it because it's look ugly. So let's say reset index. We can simply going to convert, make the drop equal to true. Okay, now it's look good. The index is gone. Head is नहीं चाहिए मुझे. And you can see reset index, drop equal to true. Not cool. This looks cool. Okay, and you also describe it, the minimum value and the maximum value. So maximum is 182 second. I hope so it's nothing but the bagging. Yeah, bagging is taking the 182 second for training this one. Okay, and we can go to the last. You can also using this technique as a same thing. Okay, now let's try to creating here a summary in a graph. It's a summary in graph. Okay, so I'm simply going to markdown, and then I'm going to paste here some code. Okay, so now I'm going to paste here the code for making the plot, and I also give here the comment as well so that you can understand. And this is nothing but for the checking that in a form of the graph. And if running this out, and you can see here the decision tree classifier, the testing accuracy, and as well as the test F1 score. You can also check in this one the classification summary of the algorithms, that how it actually look like. And you can also check in the classifications, I mean the training and the prediction score or time for each of the algorithms. So I'm simply going to pass here the another code, nothing but for training and prediction time of algorithm, Okay, let's go on here and try to do the markdown. Okay, and I'm going to paste it here the code. Well, so I'm going to paste here the code, Control B and Shift Enter, and you can see here the more take it will take in the bagging. In the bagging, it will take more amount of time, just like 182 seconds. And decision tree also taking time. Here you can see, if you see, but less time it will take in the linear SBC, the SGD classifier, and as well as the multinomial NB, I mean the naive Bayes algorithm. Now let's try to creating here on predictive system so that we can draw the predictions. So let's say data, we can take in the data from the users. Okay, it passed data on. Okay, let's say TF-IDF underscore vector equal to, we can use here the TF-IDF vectorizers. So let's say TF-IDF vectorizers. There's vectorizers, and inside that we can give in here my stopwords. Stopwords equal to my content list. Content list is nothing but my stopwords, and we have the lowercase equal to true. Then we're simply going to using here the vocabulary. Okay, vocabulary is nothing but equal to pickle dot load, and inside that you need to giving here your file name. So let's open, and as well as you need to giving here your mode. So it should be the read mode. And if I go up, then we have my vectorizer name, right? So if I go up again, you can see you have the TF-IDF vectorizers. And if I copy this out and try to paste it here, dot pickle. Okay, and we have this ones. So we already convert this into the from the vectors. So now what I can do is simply going to fit it out. Let's say TF-IDF vectors dot fit transform. So fit underscore transform, and inside that we can pass in my data, and then this is nothing but my data. It's pre-processed data. Okay, like pre-processed data. Let's say pre-process data. Pre-processed data. Okay, then what I can do is simply going to load here our training file. Let's say pickle dot load our model file. Let's say opened, and let's using here the linear SBC. Let's say linear SBC dot pickle in the form of the read mode. So it should be the RB. So what is actually linear SBC? If I go on here in my folder directory, you can see here all of the model file is created. You can see here the linear SBC because it take less amount of time. So for this kind of cases, it should be the taking the less more amount of time. If you're using the bagging, obviously for the testing one, it will taking the 182 seconds. So which one is not the compactable, right? Now we're simply going to printing here. Let's say print here. What you can do, what you can print, we can print here. Let's say trained model. I mean my model. That's my, let's say trained model. Trained model. So we can copy this out. Let's say trained model dot predict inside my data. Now if the train data, let's say if the train model, if my train model dot predict of the data is equal to 1, is equal to 1, that's mean this is nothing but one boolean. So print is nothing but one boolean. Okay, otherwise printing here is nothing but the non-boolean. Okay, non-boolean. Okay, and it also giving our data. So what you can do, we simply going to call it here. Let's say df.head, and let's copy this ones. Let's copy these ones and give it here and try to run it out. Is there any error? Reshape your data other using the reshape -1. Oh shit, I got this error because of this one. So you need to pass in here. That's why this error. Yeah, you can see the boolean, it's working fine. Sometimes this kind of thing actually happening because of the human error. And you can see the boolean. Okay, so let's say I am goat. let's say I am a goat. Let's say you are so beautiful. Let's say you are so beautiful. It's not a bowling, you can see non-bowling. Okay, non-bowling. It's really working very fine. uh, but you can also improve it. You can also improve it just by doing the fine tuning in your model. Okay, so you can also do the fine tuning. Let's try to do that. That's a fine tuning. We can go on the markdown and try to run it. Let's try to fine tune our model for getting the best parameter. So what I can do, you can using here sklearn. Let's say from sklearn dot model selection, and we can importing here the grid search cb. That's a grid search cb. And then what I can do, let's define here functions called the tuning, and then we can giving here my classifier. Let's say clf. I mean my classifier. Let's say param dict, my parameter dictionary, and as well as my x train and the y train and the x test, and as well as the y test. Okay, then we using here the make scorer. So let's say score rar. So what is make score actually? If I go off in my matrix, we already importing here the make scorer. So now it's time to using these ones, and we're simply going to calculate it based on the f1 score. Okay, f1 underscore score, and then this is my scorer. Okay, then we can using here the grid search cb for fine tuning. So we can using here, let's say grid search cb, and inside that you can giving here the estimator is equal to my classifier. Then the parameters is nothing but is coming for my parameter dict. Okay, then scoring is nothing but is coming for the scorer, is coming from the scorer. And then the cb, I mean the fold, is let's say 5, I mean my cross validation fold. So that's my grid objects. Let's say grid object equal to this ones, and after that I can simply going to fit it with our data. So let's start using here grid the object dot fit with our x train and as well as the y train. Okay, let's say y train. So that's my grid fit. So we can using, let's say grid fit. Okay, now from the grid fit we can getting here my best parameters. So let's try to use it. If you have any confusion about that, if you don't know what is actually fine tuning, you can also follow my advanced projects, just like the kidney disease, heart disease, liver disease. Just kind of projects are available in my multiverse series. You can also follow them along for getting know about the fine tuning. Okay, that's the best estimator. So it should be the best estimator. Okay, underscore. So this is my best classifier. That's a best classifier. Okay, then we can do the predictions using this best classifier. Let's say prediction is equal to classifier, I mean my this classifier, and simply going to fit it out. And then we have need to passing here my x train and the y train, y underscore train. And after that what I can do, we can do the predictions. Let's try to predict it. And after that you can passing here my x test. So that's my predictions, and then we can predict it with my test data as well. So that's my best prediction. Let's say best underscore prediction is equal to best classifier, I mean my this classifier dot predict with my test data. Okay, now we can simply going to print it out, all of the things. I mean my best parameter, the accuracy, f1 score, precision, and the recall as well. So what I can do now, so we're simply going to print it out. So let's try to print it out. Let's try to print Let's try to print first the classifier. Let's say classifier dot underscore underscore class underscore underscore name underscore underscore. Then we're simply going to print it out. Let's try to print it out. And then we're simply going to, let's say, call the best parameter. We're simply going to creating here the f string. So let's use here the f string. And then inside that, you can pass in here my grid fit dot best param. Okay, you can see it have the best params for getting the best parameter. And I'm going to copy this out and I'm going to paste it here for the accuracy, f underscore precision and the recall. Okay. शायद मैंने थोड़ा बहुत कुछ दे दिया यहाँ पर. So it should be the accuracy and then it should be the accuracy into passing the accuracy score. So what you can do, you can using here the accuracy, that's the accuracy score, and inside it we can passing here my y-test and as well as my best predictions. Let's say best underscore prediction. So it should be the same thing for all of the cases. So you can copy this out and you can paste it here. It's better you can copy this out and paste it here for multiple time. That's why this one and this one. So it should be for the F1 score. So it should be the F1 score. Oh, and this one for the precision, and this one for the recall. So you can give it here, let's say F1 score. This is for the precision score, and this is for the recall score. It's the recall score. Okay, let's try to run it out, and I'm going to copy this tuning, and inside this tuning part, I am simply going to give it here all the things. So first thing first, I need to giving here my classifier. Let's say my classifier. Okay, let's say classifier model is equal to, let's say, giving here linear SBC first, SBC. So I'm going to giving here my classifier model, and then I have to giving here my param grid, So param grid, I need to initialize it. So let's say param grid. So let's get here, give here the first C. Okay, C, and then I can giving some value. Let's say 0.25, some random value. Okay, 0.5. Let's say 0.75, 1.2, like that. I mean, just encasing with the 0.2 like that. Okay, and then we can giving here my training data, then y train, and as well as my testing data, and as well as my y test. Okay, and if I am simply going to running these ones, and you can see classify model is not defined, so it should be the CLF model, and you can see here it will working on that, set the value on that, and it will give me some kind of warning, and it will automatically taking all the value. I hope so. Name grid CLF is not defined. Okay, it should be the fit, not CLF. Fit, and if I run it out, and you can see here it will try to using this parameter inside my algorithm and try to creating here a best model. Okay, because there has no attribute called class underscore name. I think so. It should be inside here. Class. Okay, class dot. Okay, and you need to also giving the underscore. Every time actually running this code, I do this kind of mistake. Okay, it can be happening here. Yeah, you can see here the best parameter is C equal to 12, and the accuracy is nothing but 96%, and F1 score is nothing but the 97%. Precision is 97%. Recall is 97%. Quite good. You can also use here the decision tree or the logistical regressions for doing this kind of parameters. I mean, fine tuning. You can do that. If you don't have any knowledge about that, you can also follow my advanced projects in this playlist. So how I'm actually discussing all the things just for this case because वीडियो काफ़ी लंबा हो चुका है इसलिए मैंने linear SBC को select किया और parameters tuning कर दिया. Okay, so now what I can do, I am simply going to save it this out. So that's my classification model. So I am going to saving this one. So let's say pickle dot dump, and inside that I can giving here my classification model. Okay, and I'm simply going to using here the open method, and I need to giving here a name. It's called linear SBC. Okay, tuned like this. Let's say pickle, and let's give it here, and let's say WB. Okay, so let's save it, and if I go on here, you can see a linear SBC tuned model. Okay, you can use the linear SBC, otherwise you can also using here the this model as well, linear SBC tune model. So now what I can do is simply going to creating here and web applications using the Flux framework. So let's try to creating the web applications using Flux. So now it's time to creating here the web applications using Flux, and I will draw the coding part here, and we have one app.py file. It's nothing but my server file, and as well as we have a folder called templates, and inside this template folder I have all of my HTML, CSS and JavaScript file. So what I'm going to do, I'm simply going to first running this out, and I'm going to using here linear SBC .pickle file here. You can also using here the tuned one. So let's try to first tracking this linear SBC one, then we're simply going to testing here the SBC tuned one as well. Okay, so let's try to run it from here so that you can check that how the UI look like, and we also discuss about that how the HTML file is created. Okay, so it is loading right now, and we can follow the link, and let's follow the link here, and now you can see here the application is loaded, how it should look like. And let's see if I give here one text and click it analyze, and you can see here boolean. Okay, and let's give here another thing. Let's say you are so beautiful. So it's not a non-boolean text. If I click at the analyze, you can see here the non-boolean. If it is a non-boolean, it's nothing but the green signal, and if it is boolean, it will give you the red signal as well. So what we have simple one neighbor and one title. That's called cyber bullying detections using Python, and also having one text box, and as well as a button called analyze, and also one it's also button as well, like that, just like that. So here we're going to showing here our result. Okay, simple one. We need to design them, and also you can see a home, about, the contact. You can also add all of them. So let's go on here and try to understand this one. So what I can do first, we're simply going to give here one title called the cyber bullying detections, and then we have one neighbor. That's why we're using this nap expand lg neighbor dark busy dark. So busy dark is nothing but making this neighbor should be dark. Now see, this is nothing but, this is not the CSS. This is not the, it's one kind of CSS. That's mean you're going to using here the bootstrap, and you also add here the CTN of the bootstrap here, right? Then after that, we're simply going to add here one neighbor, so which are having the cyberbullying detection using Pythons, and simply having one div, and inside this div we have the home, about and the contact section that you can see earlier. You can see home, about and the contact sections. Then what I can do is simply going to creating here a container, and inside this container we have our title that's called cyberbullying detections using Python, and also we're simply going to creating here a method called a post method. That's mean it will take in the input from the users, and if the method is post, then we're simply going to call into the server. Okay, I mean we're simply going to go into our server and try to do the predictions. Okay, so from it's nothing but the method is equal to post. Then after that, we're simply going to give here one text area, which one taking the input from the users, and also having one class name, from control, and the placeholder, enter text to analyze. Then we have one button. It's not but the submit button. So inside one from, you need to have one submit button as well. Submit button as well. Now this is the Jinja template is coming from here our app.py, and if I go inside this app.py, so import here the render template as well as the request, and also import here the pickle because you need to loading here our model file. Then you also import here the tf-idf vectorizer because you need to creating the applications, I mean the projects, you're going to using here the tf-idf vectorizers. Then you're simply going to creating here an application for that, app equal to flux underscore name, and simply we're going to reading here the stopword because you need to pass in this stopword inside our TF-IDF vectorizers. So that's why I'm simply going to open it out and I simply pass here my stopwords and as well as give here the lowercase equal to and also loading here my pickle file, my vectorizer file. If I go on here, you can see here we have an vectorizer file that we actually saved earlier. Okay, so what I can do now, then we're simply going to loading here a model. That's my linear SBC model, simple one without the fine tuning. Then we're simply going to creating here a route. So we also initialize here our method. So method should be the get method as well as the post method. So if the method is post, then we can take in the input from the users and as well as we do the predictions. Get method is nothing but help us to fetch in the data from your databases, right? And then we're getting here functions called def index, and we're making the prediction right now none. Okay, by default now. If the request method is nothing but the post method, that's mean when the user clicking the submit button, the method is calling, and the method is nothing but the post method. So if the request method is nothing but the post method, we're going to take in the input from the user and try to put it inside my vectorizers. I mean, convert them into the vectorizers. Okay, and then we're simply going to pass in these vectorizers inside my model, and my model give me one predictions. Give me one prediction, and this prediction is going to as a parameter inside my render template. And this index.html is taking this one. If the prediction is none, that's mean it's not showing the result. Okay. If the prediction is equal to 1, it will showing the boolean. Otherwise, it show the non-boolean. Okay. It show the boolean. Otherwise, it show the non-boolean. Okay. That's it. How it will look like and how it will work. So simply we can go in here, just try to close this the terminal, and you can go on the terminal and you can also run in applications just like that. Let's say Python add.py. You can run in this application like this, and it will open this application in your local server. That's mean 1 to 7. You look back IP. You know about the IP. The class A, class B, class C. Okay. So 1 to 7 is which class it is? It's belong to the A class. Okay. So cyberbullying detection is used in Python, and you need to giving here one text. So let's try to take some text from our applications, or you can taking it from the data set. Let's go on the folder. We have our data set inside that. Yeah, data set. And we can copy one of them. Let's say copy this one. I'm going to copy this one. This is my data set. And I'm going to paste it here and click on analyze. You can see boolean. Okay. Let's try to select another one. Let's select this one. Okay, and try to analyze, and you can see is also boolean. Let's say he is a good boy, and if I click to analyze, and you can see non-boolean, how the application look like. You can also using here the tune one. So if I cut this one and try to using here the linear tune as well, I mean this tune one, it should be tuned. Okay, tuned, and try to save it out and try to go on here again. I think I need to yeah, I think it restart. I need to open this again. So here is the link. Here you go. Okay, follow the link, and let's try to give it here. Let's say he is a goat girl. Okay, sorry, she's a goat girl. Okay, she is a goat girl, and it's non-boolean. And let's do copy one text from here as well, because I'm not going to write it. Okay, let's say copy this out. I know it's annoying, but I have to do that. Okay, because say the bowling and how the applications look like and how it actually work. So that's it for today now, and hope you enjoy this tutorial, and make sure to subscribe to the channels and as well as share with your friends. And I'll be back with the another tutorial. So till then, take care and bye bye.